In this video, we solve a sample problem, using a systematic approach. We demonstrate each phase, with special focus on the function design. The implementation and final testing are left for the viewers to complete. Auntie Pizzeria's best-selling menu items are round cheese pizza, pan cheese pizza, and cheese calzone. John buys the pan pizza when his friends come over because it's easier to slice into equal proportions. But he usually buys the calzone when eating by himself because it's the cheapest. Is calzone really the cheapest? Write a program that lists each menu item's true value. Pizza of different size and shape cannot be compared unless we figure out the price per square inch. Then we can compare. So how do we calculate the price per square inch? If total price is for the whole size pizza, then the unit price is for 1 unit of it. Set up an equation that represents the proportional relationship. And solve for the unit price. In other words, the unit price is the price of a pizza divided by its area. For the pan pizza, we can use the area of a rectangle. For the round pizza and calzone, we can use the area of a circle. Remember that calzone is a round pizza folded in half. Pi is a constant value. And the radius is half the diameter. There are 3 steps to the program. Steps 1 and 3 are simple. In step 1, we declare variables and initialize them with the values from the problem statement. In step 3, we print the unit prices on screen. Step 2 is where the brain of the program is. And that is the focus of our discussion. This is the formula to calculate the unit price of a pan pizza. We can use a function to encapsulate the calculation steps. The function has 3 inputs and 1 output. Here is the pseudocode. It accepts width, length, and price as input, and returns the unit price as output. Inside the function, we calculate the area and the unit price. Whenever there is a division operation, think carefully whether there is a risk of division by 0. Area becomes 0 if width or length is 0. So we can prevent division by 0 by setting up a precondition. This means we have to validate the values of width and length before calling the function. Another way to prevent division by 0 is by using a conditional statement inside the function. And then set up a postcondition. This means we have to explain the negative unit price when we output it on screen. We want to keep the functions as simple as possible. So we choose the precondition method. Let's now move on to the round pizza function. This is the formula to calculate the unit price of a round pizza. We can use a function to encapsulate the calculation steps. The function has 2 inputs and 1 output. Here is the pseudocode. It accepts diameter and price as input, and returns the unit price as output. Note that diameter is an int type because we have yet to see a round pizza with the size of a decimal number. Just like the pan pizza function, a precondition is set up to prevent division by 0. Inside the function, we calculate the area and the unit price. Pi is a constant, and radius is half the diameter. Take note, if we divide by 2 here, this becomes an integer division, which truncates any remainder. The correct way is to divide by 2.0. Putting it all together, here is the pseudocode for the main program. These are the variables that store the price of each type, the size of each type, and the unit price of each type. They're initialized with a negative value and soon you'll see why. Remember the precondition to calling the functions? We do that here. The round pizza function is called only if the size is valid. Otherwise it isn't called, and the unit price of the round pizza remains negative. Do the same validation for pan pizza and calzone. Finally, we output the result to the screen. We print the unit price only if it's greater than 0. Otherwise, we explain why the calculation couldn't be done. We do the same with pan pizza and calzone. Before we move on to the next phase, let's revisit the 2 functions. They both serve the same purpose, only they have different parameters. In this case, we can overload the two functions. Overloaded functions have the same name. The parameters are different. And that's how the computer differentiates them. The success of this program lies in the accuracy of the unit price functions. So our test focuses on them. We can skip the error check for the pseudocode. As for the requirement, we output the result to the screen. The test criteria includes two types of cases. The normal case checks that an expected input produces an expected output. The edge case uses invalid inputs to see how the program responds. Our program validates the inputs before calling the function, so we can skip this case. In the pan pizza normal case, we use 1 for all inputs. This way we can easily verify the calculation. Here we use the values provided in the problem statement. Calculate. And return the unit price. Use a calculator or a spreadsheet to verify the result. In the round pizza normal case, we use 1 for all inputs. This way we can easily verify the calculation. Here we use the values provided in the problem statement. Calculate. And return the unit price. Use a calculator or a spreadsheet to verify the result. Finally, we test the calzone normal case, using the values provided in the problem statement. Use a calculator or a spreadsheet to verify the result. We can see from the result that calzone is not the cheapest. It's the most expensive. Next time, John should buy the round pizza and share it with someone.